The next thing that we're going to do is on the server side of the code, we're going to go ahead and teach our server to calculate the correct or legal moves that are possible for a given board state. We're going to use this both to check whether a move that's being passed in is valid, and we're also going to use it as a hint for the client so that the clients can tell the user what valid moves are. So let's open server.js and take a look at the place where we create a new game. So when we create a new game, we create this game object, new game, which has the state of the game. It has information about the white player, their socket, and their username. Has information about the last time the game was, last time a game move was made, whose turn it is, and what the game board is. We're going to add another property to this new game object, and that property is going to be what the legal moves are. So we'll use the new game object, and we'll add the property legal moves. We're going to set that equal to a board that looks like the one right above it, above the new game.board. But we're going to need some help in order to do that. So we'll have to have a helper function that we use in order to calculate those new moves. So we'll call that function calculate valid moves. And when we calculate valid moves, we want to calculate valid moves for which player. And so we'll use a B to indicate the black player as our first parameter. And the second thing that we'll send it is we'll send it the board that we want to have the valid moves calculated on. So what this function call should do is return something that looks like this board two-dimensional array here, but instead of having locations where the players can play, it'll have the locations where valid moves can be made for the B player. All right, so that's great. That will be great if we can correctly calculate such a, if we can correctly create such a function. So let's go ahead and write that function out. This function is actually going to be a composite of 3 different functions, and the first function is going to go through each row, each position on the board, and check that position for whether a valid move can be made. And at each position, we're going to check in each of the 8 different directions whether or not it's okay to make a move in those directions. All right. So let's start by writing our function, which is going to be function calculate valid moves, and let's make sure I spelled that right. Good. And then it's going to take a parameter which player are we checking for, and then the state of the board that we're working with. And we will start by creating a valid board, and that's going to be a local variable that contains a board that we're going to be checking on. And I'm going to copy that new game board down here just so I get the setup real easily here of an empty board. Let's see, how's that? That looks good, and I'll just line it up so it's good here. And then we're going to start with all spaces because before we check, there's not going to be any valid moves on the board. All right, then once we have a blank board that we're working with, let me close out of the function there. We're going to need to go through each row and each column of this board, and so for that I'm just going to go ahead and get some code where we've written already. So here's an example of some code where we have rows and columns. So I'm back to where I was. I'm going to put that down there. And so now we have a variable row, declare it, and a variable column that goes from 0 to 8, less than 8, and we increase row by 1 each loop, and 0 to 8, and increase column by 1 each time. And then as we look at the existing board, we'll say that if the existing board that we're checking for, if the row and the column position for that board is empty, because we don't want to check for those positions that have tokens in it already. So let's see, let's close out our semicolons, or not our semicolons, our curly brackets. And so if our position is empty for the current position we're looking at, then let's calculate each of the 8 sides, let's see, 8 sides, yeah, 8 sides that we're interested in checking whether or not it's a valid move. So northwest will be up and to the left, and so we'll have another helper function that says, is it a valid move for the color that I'm looking at if I subtract 1 from the row and 1 from the column, given my current row and my current column and my board. And if it's a valid move, then we'll return true. So that's northwest. Then if we go straight up to north-north and northeast, then what we'll do here is we'll change which way we're going to move our displacement. So north is adding 0 to the row and -1 to the column. And northeast is adding 1 to the row. Right, because we're, let's see, adding 1 to the row and -1 to the column. Wait, that doesn't seem right to me. Our row for west is -1. No, row is what we care about for north. So that's going to be subtract 1 from the row, that goes north. And our columns go left to be west, so that's -1. And north is going to be 0 for going north. And then our columns will be row, it's -1. Wow, I can't think straight. And then our east is going right 1 on our columns. Okay, so that's upper left, that's up straight, and that's upper right. Great. So those are our 3 norths. Let me copy them here, and we'll make 3 souths, since that's sort of analogous. Rather than going up in our row, we're going to go down in our row. Add 1. Okay, and then we'll have to have a straight west, and that's if our row stays the same and our column goes left. And east is when our row stays the same and our column goes right. Great. All right, so now we have 8 different conditions that we're checking. And then what we're going to do is we're going to say if any of them are true, then we're going to say that this is a valid, the position we're looking at row and column is a valid place that we can move. Okay, so if looking northwest indicates that it is a valid move, or north-north, or northeast, or west, or east, or southwest, or south, or southeast, if any of those things indicate that our current position is a valid move, then we're going to update our valid data structure at the given row and column and say that that position can be played by who. And close out with semicolon. And then as we go all the way down to the bottom, we will return our valid, our two-dimensional array of validness, I guess, of the positions that are valid. All right, so that means that now we have to check that is the current position a valid move based on looking left, looking in this direction. So let's add our helper function for valid move. Valid move is going to look down each one of these rows, each one of these lines of sight, and determine whether or not we have a valid move. All right, so let's see. What we're about to write is the function valid move, and that is going to receive a who, a delta row, a delta column, a initial row, an initial column, and a board. And great, and that is going to return true or false based on what we got. And what exactly is this function doing? Well, it's going to check if the position at RC, R comma C, contains the opposite of who on the board, and if the line indicated by adding dr to r and dc to c eventually ends in the who color. All right. So first let's figure out the opposite of the color that we're looking at so we can compare whether or not we're ending with that. So we'll start with other, and if who equals black, let's do a triple equals there. Then other equals white, and an else. Wow, my indentation's not helping me out here. If who equals white, then other equals black. And what else should we have? If we have anything else, we're going to have a problem. So we'll just say log Houston, we have a color problem. And we'll log what color problem we have. In which case, we will just say that this is not valid. All right, but if we have a good function call, then we will say that if r plus dr, so going the direction we care about, if that's less than 0, so we move off the board, let's see, two conditions here, or r plus dr is greater than 7, then we go off the board the other way on the rows, then we're going to return false. And we want to do the same thing for columns. So if walking off this position one way, oops, so columns plus DC, and columns plus DC, if that walks off the board, then it's false. We don't have a valid move. Then if moving one position doesn't have the opposite color, then this isn't a valid position. So if our initial position plus our delta row, or initial column plus our delta column, if that's not equal to other, then this is not a valid direction. This direction doesn't make the position a valid place to play. And then finally, we're going to walk down that direction and make sure that if it did end with, we're looking at one particular position, and then we're looking at the position next to it to make sure that it is the opposite color. And then we're going to continue and make sure that if it's the same color, at some point, I mean, if it's the opposite color, which it has to be in order for this position to be a good play. So if we play black, we need to make sure white's next to it. And then we have to make sure that that white line eventually ends in black, or the black line eventually ends in white. So if it's not equal to other, then that's false. And now we need to make sure that two away don't end up in off the board. So we're going to take r plus dr less than 0, and r plus dr greater than 7, then that's a problem. And dc plus dc, that's a problem. And then lastly, we're going to check to see if the line ends. We'll say we'll use a helper function that we're about to make. We'll say if check line match, and we're going to say who, dr, dc, and r plus dr, and c plus dc, comma board. So not if, I guess we'll just return what that returns. So to give you an idea of what I'm thinking here is that we're going to take a position. All right, so R is the position we're checking. We know that if we move 1 to the row, 1 on the row side and 1 on the column side, we have the opposite color. And so now we're going to go 2 in the direction that we indicated. And we're going to make sure that that is eventually, if we keep adding that amount to these rows, we're going to end up in the same color because the one right next to us is the opposite color. So making sure that we capture it. I'm not explaining it very well, I apologize. All right, so then we need our helper function for check line match. What this is going to do is this is going to check if there is a color who on the line starting at RC or anywhere further by adding dr and dc to r comma c. All right, and then the function is check line match, and we are receiving who. Oops, lagging here. Stop lagging. dr, dc, r, c, and the board. And okay, if the current board position that we're looking at, RC, equals the color that we're trying to end our line on, then everything is good. All right, and then I'm going to come down here and grab this walking off the board code. I'm going to say if taking one more step walks us off the board, then that's false. Otherwise, we're going to do a recursive check. We're going to say return check line match who dr dc r, take one more step, r plus dr, c plus dc plus board, and we'll return whatever we get there. All right. Okay, so I think that's good. Let's just walk through and make sure that we didn't have any typos or errors here. So our valid array looks good. Our two-dimensional loop looks good. We go through each one of our positions, northwest, north-north, northeast. And then we go west-west, east-east. That's good. And then southwest, oops, that should not be south-north. That should be south-south and southeast. Northwest, north-north, northeast, west-west, east-east, southwest, south-south, southeast. That's good. Okay, and then we call our valid move function. And valid move function is who. We check who equals B, other equals W, and that with a semicolon. Forgot that. And other equals B ends with a semicolon. Forgot that. And log Houston, we have a problem. There's an extra single quote at the end of that who, so I'm going to clean that up. And that looks good. And let's go to our check line match functions here and see if we have any errors up there. Oh, let's see, this shouldn't be plus board here in our recursive call. At the end of this last line, this should be calling the board itself. And the name of this function isn't matching. This function needs an H on the end of it. Mess that up. All right, let's see if there's anything else that I can see as we're just looking right here. Okay, so if everything goes well, that should calculate all our valid moves. And when do we want to calculate those valid moves? Well, we want to calculate the valid moves when we create our new game. So here's our create our new game. We calculate our valid moves then. But we also want to calculate valid moves after the player plays a token. So let's go to the play token function. And as we come down to the response after the player plays a token, after we execute the move, we want to say that there's a new set of legal moves, which is that the game.legal moves equals calculate a new set of legal moves for the player black, now that it's black's turn, given the current game board. And likewise, after we make black's move and the move becomes white, we'll make all the legal moves for a white player's board. Okay, and now we don't have any enforcement on the client side, but that should at least pass our starting routine for our board. So let's just make sure that we can start our server with Node.js. Great, so it's running, so we don't have any immediate errors. And let's just make sure that if we start a game, we don't have any trouble. I'm white, it's black turn. I'm black and it's black's turn. Go here. And we did get it. We did get one problem here. Calculate is not defined on server 717. So let's check that out. Go to line 717. It says, oh, calculate, right. So just calculate isn't the name of the function. It is calculate valid moves. Save that. Save that, and try one more time. And I'm white and it's black's turn, I'm black and it's black's turn. And it's fine, we're not enforcing it. Oh no, played out of turn is being enforced, but the valid moves are not being enforced. We're calculating them, but we're not enforcing them. Okay, so the next step will be to enforce them. That'll come next round. All right, thanks for your attention.